I guess that means yes.
Well, good morning, everyone, and welcome to the last RMM University of this semester. Before we get started, I just wanted to thank all of the people who have contributed to this year's RMM University. So in particular, our AV team, John Maxwell, Mark Skelton, and David Maserowski, who are the ringleaders, and also everybody else who helped, Chris Keller, Dirk Melch, Doug Sharp, Paul Olson, and I'm probably leaving somebody out. So really appreciate everybody who has come out every Friday before RMM University, set things up, and then participated during the actual talk to bring you the video feed. So very much appreciated all of your efforts. Of course, I also want to thank our presenters, in particular our presenters today, James Cizek and Jim Dixon. They've both been dealing with some issues here over the last several months, and so we had to postpone this a couple of times, and we really appreciate that despite their hair being on fire, they took the time to actually prepare this presentation for us. Also, all of the other presenters that we've had this year, Doug Sharp, John Maxwell, Dave Maserowski, Mike Lozano, Mike Papas, Tristan Honscheid, Chris Kellen, and Glenn Recker. Thank you for taking the time to prepare these RMM universities over the last year. And then, of course, N0 POH Wayne, who's our treasurer, and manages all of the contributions that people have, and whom we go ask to buy the equipment that we need to bring you this RMM University, and Desiree Backus, who's our PR person that helps promote RMM University. But most importantly, all of you who have contributed to RMM, come to these RMM Universities. It gives us the incentive to keep on bringing you these presentations. So very much appreciate everybody who participate and contribute to RMM. With that, I will remind you that RMM is a 501c3 public charity, and you can visit our website, rmm.org, to see various ways that you can contribute to RMM. As I've said, this is our last presentation for this academic year. So if you have specific topics that you are interested in hearing about next year, please let us know. Drop me an email, willem@printmath.com, or you can just send us a message through the RMM website about topics that you would like to hear about. And in particular, if you're interested in presenting in RMM University, we would very much appreciate it if you let us know. Or, of course, you can always volunteer somebody else, which is how a lot of these happen. So without further ado, we'll turn it over to James and Jim. And thank you very much again for being here today.
Thanks very much, Willem. Welcome, and thanks everyone for joining us today. You know, as Willem mentioned, we've had an unusually large number of things with family and health and all these other things to delay this, but happy to finally get this delivered and hope everyone finds it useful. Want to introduce Jim here as well. He's got a significant background in 3D printing and all kinds of other maker type things, K6ETE. And hopefully today we'll walk you through two of the most prominent versions of additive making here.
Hello, I'm Jim Dixon, K6ETE. Hope you get some good information, knowledge on 3D printing, and especially how I personally use it for a lot of stuff in amateur radio. Definitely helps me out a lot in prototyping and troubleshooting, broken parts, fixing and repairs. So hope you enjoy it.
So moving on to our agenda today, this is just a rough area of topics that we're going to step through. kind of talk about what 3D printing is, the most common types. We'll walk through the processes of 3D printing and modeling. Jim will do some demonstration of a bit of the design work that happens ahead of the actual printing. We're going to spend a majority of our time talking about filament printing, which is usually the entry point for most folks into 3D printing and is probably more prominent. However, we're also going to cover resin printing. We'll talk about the software that is required after the model is designed and that turns it into something your machine can print. We'll work through and talk about the machines themselves and some of the differences. Prep work, common problems, mistakes, and how you learn, and some of the gotchas of each of the types of printing before we kind of wrap up with a troubleshooting session, and that should do it for today.
What's I guess I could go over there. James mentioned earlier, 3D printing is also known as additive manufacturing. You're adding lines. Everything is done in layers that can range anywhere from 0.04 millimeters up to generally 0.32 millimeters in thickness per layer, all depending on the resolution you want. Also, a lot of quick prototyping designs. If you look in the pictures right there, the upper left-hand side of the screen, that box is one that I designed for James in about 10 minutes, which was for the
Masters Communications audio interface box that we use for VARA.
Yeah, he called me one day and I said, hey, can you make something for this? He sent me the dimensions he needed and I had it done in about 10 minutes in printing. So very quick and easy. In the far right, I do a lot of antenna prototyping and trial and error. The right side is a cubical quad antenna for 2 meter that I made for with arrow shafts, the aluminum arrow shafts for the spreaders. So there's a lot of different aspects you can use it for.
And there's an example that Jim
that's for a piece of 1-inch PVC to use, kind of simulates the arrow antenna for a Yagi antenna. They just clamp over top of a piece of 1-inch PVC and put as many elements on it as you want. Most common types of 3D printing is the FDM, or filament
fused deposition modeling.
Fused deposition modeling, which is the filament type printing, which is the entry level, a lot more user friendly, a lot easier to do, cleaner. The resolution isn't as high as it is with the SLA or resin printing. Resin printing uses a lot of chemical additives for cleaning, post-processing, which they recommend using PPE for, to where most common FDM printing, you don't need to worry about any PPE equipment. It's fairly safe.
Yeah, for sure. And we'll get into resin printing a little bit towards the back end of the presentation. It's just as easy, if not maybe a little easier than filament printing. But as Jim mentioned, there's a lot more safety issues with it. It's a lot more cleanup to do, and depending on what you're printing and the types of resin, it can be more expensive. Resin printers, however, have started to drop to the point that they're pretty competitive with filament printers.
Process for 3D modeling. Basically, you want to design your 3D model. You can purchase or find designs online for free. After you're done with the design, whether you get it or not, I can't see that screen up there too good. The file preparation, whenever a 3D model starts either as a STL file or a 3MF file, it's the file format. You need to convert it put it into slicing software, which will convert it to a G-code file for the printer to read. So there's a little bit involved there.
And it's kind of important. So there are as many file formats out there as you can ever imagine. And some of these software packages will support one, some of them will support many. But the two that Jim mentioned, STL and 3MF, right,
Yeah.
are probably the most prevalent there. So it is something to be aware of when you're selecting software and when you're selecting, your hardware after the fact, that you want to get something that's both usable and supports these common standards. With the flood on the market of cheap overseas things, that you don't always get the most flexibility at the lowest price. So being just cognizant of what what the capabilities of both the software and the hardware are is important in that space.
Yeah, there's most of the modeling software, majority of it you're going to see is going to be popular modeling software. Autodesk Fusion 360 is very common. It's one of the industrial standards that can be used for 3D modeling, CAD or all CAD design. Shaper.
I think you can get a free version of that, right?
You can get a free version that has to be renewed yearly, but it's very limited on its functionality.
But it's a way in to
Yeah,
start.
it's a way in to start. Shaper 3D, if you like to use tablets and touchscreens, Shaper 3D is optimized for tablets and touchscreen use. It's one of the only ones and the best one that I have found that I use a lot of. I use the Shaper 3D and the Autodesk Fusion 360. Tinkercad and FreeCAD are online web-based 3D modeling, which are more designed for 3D printing. They said they're free, but they are online based, so if you don't have internet connection or spotty connection, it can be difficult to use, but they are free, so it's also a good entry point. You can find, before you have to design something yourself, there's multiple websites where people design stuff, publish them for free. They include Thingiverse, Thangs.com, Printables.com, and Cults3D are four of the big popular ones.
And those sites, some of those sites are absolutely a wonderful way to get started in this, especially as this 3D printing relates to ham radio. If you go there and say, end-fed half wave and type it in there, you'll find all kinds of models for winders and antenna supports and storage systems and everything else with the STL files ready to go. Everything on there is released under the Creative Commons license or a similar open source type licensing so that you're free to use it for your personal use. It's as simple as downloading the files. They often come not only with the 3D modeling file, but there's often image files to show you what the finished part looks like, and either PDF or text documents with any details about, do you want to use, it will get to the details, but it may give you details about infill and print density and things that are important to make it a successful print.
Yeah, definitely. They're definitely worth it for the beginner. They're starting out. I know I used Thingiverse religiously when I started out. I started out got my first 3D printer almost 11 years ago. So when it was really new, and then started getting into doing design work and everything else afterwards because I wanted to sell products also. And when you get them free online, you can't sell them commercially. So had to learn how to start designing and prototyping my own.
And I have zero.
Will you guys be providing links to all of these in the slides? All of the software and sites that you've mentioned?
Yeah, all of the links for the sites are in the slides. The slide deck, slideshow presentation will be available afterwards. So I know some of the slides have a lot of text that we're not going to cover, but that's for future reference, where people can go back and review it after the fact easily.
If you want to ship it to me at the break, I'll upload it to Syllabus.
Okay. We'll get it over to you, John.
I think that's everything on that one.
Yep. So the yep. So John, I'm sorry, Jim talked about all of the software and where to get the models. I still use a lot of those sites first before going to design anything because I'm terrible at it. I have no artistic talent whatsoever. And you know, if someone else has already done it, it's neat to go look at that first, and then you know, if you can't find what you're looking for, you can design it.
Yeah, I was just going to point out one thing. If people have got questions, you can either type it in the chat or come off mute. We do have two-way audio here with the presenters as we go through. Figured I would just put that out there.
Thanks, Mark. All right, STL files. You want to talk about?
The STL file play a crucial role in 3D printing workflow. STL is the most common with FDM or filament-based printing, to where the what is it? You upload the STL file to the slicer software. We'll cover some of the different slicer programs that are out there.
And so when Jim, we'll get into slicer software, but just so that we're following along, that's the actual base for how both of these technologies work. When you take a 3D model, which is a solid thing, in order to make it with either of these printing technologies, you have to slice it into layers from the build plate upwards till it's finished, and this software is what determines how to generate the machine code, or G code is often what they use, various formats of different code. It takes that into little tiny slices and generates all the X, Y, and Z information for the printers for each layer as the model is built.
Yeah, it's easy. One way to explain, I'm sure everyone's seen the type of image that you'll see from auto manufacturers. You'll see a whole bunch of lines that create what looks like a 3D image. Those are generally STL files or something similar to an STL file. For reference, it gives an endpoint, start point, end point, midpoints for each line and each layer that the model has to follow. 3MF came out. Majority of the use for it is 3D modeling. 3MF is 3D manufacturing format.
Yeah, and STL is stereolithography.
Some of the printers you get that will have multicolor prints generally use 3MF. 3MF file can support up to 20 different color changes or filament changes during a model print, to where STL is generally only good for 1 to up to 5, depending on how good of a printer you have.
A lot of detail on these first couple here as we get into things, but after we get through the base of some of this, we'll go into some demos and show you some parts.
Yeah, I mean, it's regardless, if you find or design your own 3D model, you'll have to decide which type of file to use. Like I said, most standard, easiest to use is going to be the STL file. This goes into more. Popular sites to search for 3D models, Thingiverse. There's also one that I didn't mention earlier, which is STL Flix. They kind of did a parody of the name for Netflix. They did STL Flix. That is a subscription-based place to get files, but with the subscription, you can use it for commercial use. You can, if you have the subscription, you can print files and sell them.
So moving into downloading and printing, and now into some of the making here.
Yeah. Like the cost involved, generally for the Autodesk Fusion, I don't think I put that one on there.
Yeah, it's at the top.
Well, I have it there, but they have the free and paid version. The paid version, I want to say if you pay for Autodesk Fusion, is $499 a year or more. That's their basic version, which can go up to, I think their most expensive one's about $8,000 a year.
Yeah.
But the Shaper 3D, which is the one I personally use, starts with an annual subscription of $299. But if you're using it for commercial use, it's well worth it and does 90% of what the Autodesk Fusion does.
And then there's a couple of free ones that Jim's listed here, TinkerCAD and FreeCAD. There's actually so many free CAD programs out there on the market, it's unreal. Yeah. And the amount of value you get varies with the free ones. It's also, some of them are very powerful, but they've got a tremendous learning curve. They're very difficult to learn. So finding the balance between something that's somewhere between free and affordable and usable and learnable is the key. And I, unless Jim's got some answers here, I've found that there's not a whole lot of guidance on that other than, what I personally do when I'm exploring some of these new options. I usually try to find some YouTube reviews, and that your mileage may vary with that because it's the internet and anybody can put anything there they want. However, once in a while you'll come across someone that's actually pretty talented with a lot of the software, and they give you some tips. It's a good starting point, at least, to figure out which ones you want to download and try versus move on and try to find something else.
That's one thing I found with the free ones, like TinkerCAD is a big one. The big learning curve is you essentially have to start with a basic 3D shape and then cut it down to what you want. To where some of the other ones, especially the paid versions, you can start with a 2D object and then extrude it to a 3D object, to where you're engineering it the way you want it instead of reverse engineering a basic object.
And that's one thing a lot of these software packages have gotten better at. There used to be, with a lot of 3D software, it was on you to design all of the volume of the design, right? 2D is fairly simple to design a shape, but then building it into a 3D model was used to be very difficult. Most of the software, especially these paid versions, I use Fusion 360 myself, have gotten to the point where if you want to make a cylinder, you draw a circle, and then you'd use an extrusion tool and draw it vertically, and it then builds you a complete 3D model of the cylinder that you can do things with from that side. That used to be a tremendous amount of programming and drawing work to do that.
Used to be a 10-step process. Now it's a 2-step process.
So it is worth looking at the paid versions of things, even at the basic level, as they typically can save you a tremendous amount of effort, time, learning curve, frustration, things like that. If you're going to learn something new, learning something that's actually very usable there is worthwhile often.
Yeah. One of the things about FreeCAD is, one of the things I do is design circuit boards using KiCad. And when combining, let's say I design a part that I'm going to 3D print and then attach it to a circuit board, you can import FreeCAD, the 3D model, and then use it in the PC board design software. Mm-hmm. So those two tools actually work quite well together.
Yeah.
Thanks, Dave. All right, so we got some of the initial basics down on what is filament printing and what software to use to design. Did you want to show, before we move past design, do you want to show some, or is that coming up?
We can. We'll do it coming up after we go through stuff. Later on, we'll show some of the basics for 3D modeling using software. and some of the other aspects of it with the slicing software, stuff like that. So we'll go over that later in a little bit more detail. That way we can have more time to answer questions if anyone has questions about 3D modeling. The common FDM filaments, I know these are the base filament. Everything you can get additives mixed in with it. The most common is PLA and PETG filaments. They are both safe for printing, no health hazards or anything involved with either one of them filaments. They're cornstarch based and all natural based. PLA is polylactic acid, and the PETG, I can never remember the first word of, is the polyethylene terephthalate glycol. And so they're safe. Generally you don't have to worry about fumes. You don't want to do it in a very confined space, but if you have an open basement, open room, they're both perfectly safe to print with. ABS and ASA, are stronger filaments. You need a well-ventilated room and a ventilated printer with an enclosure. You do not want to breathe the fumes from either one of them types of filaments. So if you're just starting out, definitely recommend PLA or PETG. PLA has a very low glass transition temperature where you won't be able to use it outside in direct sunlight or in a vehicle if you're modeling anything or prototyping anything, where PETG has a significantly higher glass transition temperature, generally 75 to 90 degrees Celsius for PETG, which translates to about 140 degrees Fahrenheit, roughly.
Talk about glass transition.
Yeah, the glass transition is where the material becomes pliable and starts to lose shape and can be deformed from weight or bending or any type of pressure. So if you use PETG and the glass transition temperature is 55 degrees Celsius, you put it in a car and it reaches 110 degrees inside because it's inside a vehicle, you're going to come out and it's going to be significantly deformed and not operational anymore.
Yeah, PLA is by far probably the most standard thing that everyone starts with, and it's probably the most forgiving filament to learn with. However, I have found that the brand and the color of the filament play a big, have big implications as to the difference. You cannot just pick one and then expect, dial all your settings in and expect all PLAs to operate the same way.
Color has a big effect on printing. Just the dyes that are used change the characteristics of the filament. You can also, with PLA, they have PLA Plus or PLA Tough filament, which is slightly higher in the glass transition temperature and printing characteristics. You can also get, if you go to PETG filament, you can get stuff that is impregnated with carbon fiber strands, with wood fibers, with rock pieces in it, where it's almost like a replica of a marble. There's a lot of different stuff available that changes the properties of it. Starting to use a lot of PETG filament with carbon fiber embedded in it. We found that it is actually acting stronger and durability better than ABS filament. ABS is the same thing they make all the plastic trim pieces on your vehicle cars out of. It's all ABS plastic.
It's also important to note that you cannot just pick any of these filaments and print them out of your machine without changes. The nozzle type and the temperature of the what they call the hot end, we'll get to that in a bit. There's differences in the machine setup and the machine requirements to print these. If you're all set up and dialed in with a brass nozzle and the temperature range on PLA, you can't just switch to ABS. It will not only not print correctly, but it'll slowly destroy the machine. The abrasiveness of those filaments will destroy the brass nozzle and increase the diameter of the hole, eventually leading to either a failed or impossible print.
Yeah, I know. Well, if we want to, over here, this printer is James's printer. The hot end that he is referring to that the filament comes out of is this front piece right here. This front piece, there's a heat block inside that can reach up to, with this printer, probably about 230, 240 degrees Celsius, which is extremely hot. Generally with PLA printing, you're printing at 190 to 205 degrees Celsius. So gets very hot and can be dangerous.
We'll go over the pieces of the printer as we move on, because there are many different setups in how the hardware works and what some of the advantages and disadvantages of them are.
Slicing a 3D file, the images that you see, the top left is a 3D model. The lower left is when you convert it to a sliced model, or in the slicer software, you can see all the infill. It doesn't fill, it's solid unless you tell it to. You can have anywhere from a 5% infill up to 100% infill.
And as we get into slicing software, we'll talk a little bit more about infill. I think a little hard to see in that. I think the infill is triangular in that particular one.
Probably gyroid.
Okay, so there you can cause an infill is the structure inside of the solid piece. So that's what gives gives it the structure. It's almost like building a bridge, and all the infill would be all the girders inside to give it support. But as Jim said, you don't want to do 100% solid infill.
No.
For a multitude of reasons.
Yeah, weight, cost, efficiency, speed. I've found through a lot of testing, wall count can add, the thickness of the wall or wall layer lines can add more strength than increasing the infill. Generally, you want to stay around a 15 to 25% infill for most things.
And believe it or not, a properly infilled part is almost always stronger than if you had made it a solid part.
As it uses triangulation for strength, and we know that if you take a couple pieces of steel and triangulate them, it can be stronger than a solid piece of steel.
Mm-hmm. So moving into slicing software, this is another area where there's so much variability and there's so many options out there. But there, of course, are some great recommendations for starting. If you look on the right side of that slide, you'll find probably the most commonly used and the most commonly talked about slicing softwares out there. Many of those have both a free and a paid version. Unless you get into really heavy duty detailed things, the free versions are almost always going to do everything that you need to take you past starting out. You can go to full production with most of these software. Ultimaker Ultimaker is a company that makes 3D printers. The Ultimaker printers and Cura is a free software that they release. It's also, you can buy a paid version of it, but Cura not only works with their 3D printers, but they have a list of about 300 printers that they'll work with.
I use the Cura for slicing for the FDM printing.
And so do I. Cura is just a fantastic, easy to use piece of software. You load it up, tell it what machine you have. It knows about just tons and tons of machines. You tell it what kind of filament you have. It knows about tons and tons of those, and it brings in all of the basic settings for you. And for the most part, you can generally print your first thing just like that successfully. I've added a couple at the bottom there, KI0KN and Lychee Slicer. Both of those have free and paid versions. Both of those do work for filament and resin printing. I have moved now to the Lychee Slicer for resin printing. It's that's the one that I recommend now as the equivalent of Cura for filament, as providing the same ease of use, flexibility, power, etc. for resin printing, although they are capable of doing filament as well. But I agree with Jim. I think Cura is the best starting program,
Yeah,
and probably one you'll never need to move away from for filament.
No, filament printing, that's the best. And you also have to remember almost every FDM printer you can buy, the manufacturer have their own software that you can use that is only available for that piece of equipment. I generally tell people if they tell you to use that, use the Cura or Prusa slicer. It'll work with it. The standalone software available for most manufacturers is not worth it. They're very limited, and it doesn't give you many options for adjusting for your printing style.
Yeah, I agree, Jim, and it's absolutely amazing the flexibility that these do. As I mentioned, when you enter your first pieces of data, it'll bring in the default settings. But if you find that you've got a specific part, a specific job, or something about your machine that requires some adjustment, they've got massive flexibility to account for that and adjust for that.
This is where it gets into with the 3D slicer, primary settings include the speed, layer height, nozzle temperature, bed temperature, if applicable. PLA printing generally does not require a heated bed, to where if you get into the PETG or ABS, ASA filaments require a heated bed. Heated bed prevents the model from cooling too quickly. If it cools too quickly, it will start to warp and you'll get adhesion issues and everything else. Wall count, infill density, and bed adhesion.
Even though PLA doesn't require a heated bed, if you are not currently doing 3D printing and have learned, I would highly recommend you start with a machine with a heated bed anyway. It will save you a tremendous amount of headaches. Even though PLA is printable without a heated bed, you will have challenges getting the models to stick and stay flat without a heated bed. If you have the heated bed option, which honestly at this point in time, the market, even the most basic machines, the machine right in front of us that we'll be looking through the parts earlier, that's I think a sub $200 machine, and it comes with a heated bed. It will give you not only flexibility into the future, but it is just so much easier to learn on if you don't have to fight temperature.
That's good point. Get a heated bed to start with, and you never have to worry about it.
And the neat thing is that if you're patient, there's a lot of settings that you can play with to learn how the best ways to move forward with are.
This slide shows some of the different settings with the 3D model. You can see that this is using the Cura Ultimaker modeling software, the different settings in there. This is referring to bed adhesion. There's three different types they call it bed adhesion, but what it really is a primer for the nozzle to start printing. The skirt, brim, and raft. A skirt is just one or two lines that are spaced away from the 3D model on the print bed. The brim, it just prints. You specify how long you want it to be and how many lines you want it to be around the model. It doesn't directly attach to the model, other than very minimal around the edge to help. If you're printing a really small part, it helps keep it attached to the bed.
Think of it as a hat brim.
Yeah. A raft is 1 to 2 millimeters thick, and is the part that you're printing prints on top of the raft, almost like if you're on a raft out in the middle of the river or lake.
And those can be as Jim said, there's actually some time to use each one of those settings based on the part for small parts or thin, wide parts. But they're also really good troubleshooting things too. If you're having problems with bed adhesion, which is one of the most common problems, we'll deal with that, or we'll talk about that later on in the presentation. But if you're having problems getting your model to stick to the bed, just simply turning one of these on can often help you get it to stick until you can figure out what the ultimate problem is.
Yeah, I anytime I start a print, there's at minimum a skirt around the print.
Yeah.
It allows you to look to double check your distance that the nozzle is from the bed on your first layer, which is the most important layer when printing anything.
Yeah.
This is just a picture of the brim is the single layer of lines around the outside that just attaches to the bottom corner. If you look, when I'm printing this is actually a sliced model of a insulator I use for antennas, which is very small. The base of it sitting on the printer is a 1/4 inch by a 1/4 inch that is kind of in an X shape, so it's not even that much on the bed. I will use a brim around that to help adhere it to the bed.
Yeah, especially if you think about it, as Jim said, that's only a 1/4 by 1/4. And how tall is the insulator?
The insulator is about 2 inches tall.
So if you think about because printing is not a zero drag, the print head, as it's printing through the filament, it is not actually just setting in, think of a tube of toothpaste that's held above a countertop. That is not how you print. The print head is actually embedded a bit in the filament and squishing it out. So there is drag on the part from the print head. So if you've got this 1/4 inch square part that's 2 inches high, that's quite a lever arm, and it's the printing itself, if nothing else is wrong, can knock that part off the bed. So when you're looking at that kind of bed adhesion, these are lifesavers to make it work.
Well, actually, on this model right here, if we can get Doug's camera, if you look at this corner right here, you can see a small defect in the bottom. This was started to print, and this side from about here to this end did not adhere to the bed properly, which caused it to lift off the bed and shift to the side. It printed the rest of the model good, but because of that bottom defect, it's still usable if it was at my home antenna, but it's not something I'd want to give to anyone else. That's just one of the many issues you can have with bed adhesion.
Bed adhesion is absolutely one of the most critical first steps in succeeding in this. Oh, and I think we kind of covered this earlier. The infill density is getting infill density proper is one of the most important parts for your part's strength. And contrary to belief, infill can be stronger. Oftentimes is stronger than a solidly filled part. Anything else to add on that?
No, I mean, like I said, mentioned earlier, strongest infills that I have found are 15 to 25% infill. Anything above that is you're beginning to waste filament and time. The time's calculated by the amount of filament per layer, and anytime you can cut that down, you're gonna save time printing.
And that's a good point. A little sidetrack there. This is not a fast process. 3D printing on either FDM or resin is not fast. It takes a long time to do these prints. Of course, it does change. There are faster printers and slower printers, but time savings is worth considering because it's the longer your printer's on. I mean, that's more wear and tear on your printer. It's more filament used. It's more everything, right? So. Although it's not always best to minimize the time to print, it's certainly worth considering when you're, the overall production of your part, the time it takes. And we got another little bit of an eye chart here to run through, but as we said, A lot of this data was put on these slides for publishing later, so that everybody can have detailed descriptions without the video itself.
Just real quick on here, it shows. Just go over a couple things real quick on here. The print head extruder. This would be the print head hot end of the nozzle on James's printer. Back here is what technically the extruder is back here, because this is what feeds the filament back here.
You could go to Doug maybe.
Yeah, we can go to Doug's camera. This is what's considered a Bowden tube style printer, to where the feeder, your filament will come into this piece in the back and go through. There's a small gear drive that'll push the filament through the Bowden tube into the hot end. That also limits what you're able to print. They have some filaments that I didn't go over, like TPU filament, which is an elastic-based filament where you can make phone cases and stuff that has flexibility to it. That can't be printed in here because of the Bowden tube. The elasticity in the filament won't allow it to retract and feed properly. Another thing to look at when you're buying a printer is what type of filament you're going to be doing. The printers I use are a direct drive printer, to where the gears and everything that push the filament into the hot end is directly above the hot end, where it's direct into it. Yeah, this is one of the very first items that I modeled and printed many, many years ago. I designed this. It is actually a working paddle that I designed it with bearings for the top and bottom of the paddles, magnets inside to keep it separated, which is fully adjustable for how much throw you want within it. And it plugs in with a 3.5 millimeter jack directly into a radio. That was one of the very first items I designed and printed. I want to say that was around 2014, 2015.
So Jim talked about, the main pieces on the printer itself to get the filament from, in this particular printer, the filament rides up here on the top. And it comes down, feeds through here there's a stepper motor in the back of the printer here that drives with two brass gears that drive the filament down into the hot end. And the hot end itself is, I can't remember, do we have details on this later?
I believe so.
Okay, we won't get into too much of that, but the hot end here basically has a heating element and some cooling fans, and it pushes the filament through, and underneath here, it may be hard to see, there's a tiny brass, in this printer, a tiny brass nozzle screwed into the hot end that actually has the diameter hole that the filament pushes out of.
Standard diameter is 0.4 millimeter size hole that you're extruding the filament through.
Yeah, and there's a Teflon lined tube in that hot end so that the filament doesn't get stuck as it melts. Because as the printer is printing around and filament is going through, anytime the print head needs to move from one spot to another or change, from one spot to another, the motor will actually draw the filament back a tiny bit. And then the head will move, and then it starts pushing it out again, so that you don't have a string of filament stringing between the pieces. All right, so moving on to parts of the printer. More parts of the printer.
More parts of the printer. So this printer is a Bowden feed setup. The Bowden tube style and the direct gear drive or direct feed, my first printer was a Bowden tube. After that, I went to direct feed because I wanted more flexibility on what I was printing. Other parts of the printer, obviously the print bed or your print surface. This printer is also what has been termed a bed slinger because the print bed will move forward and backwards to allow printing for that axis, to where the print nozzle will only move up and down and right and left. Newer style printers that they found are faster, the bed moves up and down and the print nozzle will move right and left, front and back, to where it's a lot less moving mass, which allows it to move faster for printing. Those printers cost a little bit more than this style printer. This is the cheapest style that you can get anymore. If you have funding and can get one that the bed moves up and down and the print head does all the other movement, is definitely a better option if available to do so. There's nothing wrong with these printers, they're just slower.
Plus, the other advantage to, and as we get into this a little bit deeper later with the setup and troubleshooting of the printer, if you look at this printer bed, you'll see that this entire bed is balancing on this little tiny rail, this less than an inch diameter aluminum rail. The bearings, you can kind of see the roller wheels under here on left and right. That whole bed is riding on a set of bearings in there, and so there's a fairly, it's not as stable as something that might have two rails, which the beds that Jim is talking about that move.
Yeah.
The bed moves up and down. They'll have at least two rails supported on the outsides. So this one, there's absolutely nothing wrong with this, but one of the side effects of having the single rail printer with the moving bed is that leveling the bed side to side is hypercritical and very easy to knock out of alignment. We'll also talk about auto bed leveling later, which this machine now has. But it can only work within a certain, you have to be really, really close. It can only make up for a certain amount of unlevel. Once you're beyond that, it's not able to do that. And we'll talk about how that works after the break.
Yeah, like I mentioned earlier, you're dealing with a print layer. My standard print layer height is 0.16 millimeters. So if your bed's out of level 0.02 millimeters, you're gonna get a poor print.
Yeah.
So it's
the tolerances are very, very small.
Yeah.
And then as we're talking about the bed where the print is built from, there are a lot of materials and materials that the bed can be made out of, and materials that your print will stick to. Is this particular printer, and this is a heated bed, but if we remove these pieces here, we can see that this is an aluminum bed. If we move into Doug's camera, please. This is an aluminum bed here that's got a heating element underneath. And this is actually a glass plate. You can see the reflection off the plate that's sitting on top. We'll further get into this glass plate has a PEI coating adhered to the top of that, which we'll talk about in a minute. But the glass is inherently very, very flat. So glass is a fairly inexpensive way to ensure that the surface you're building is very, very flat. However, glass is also very, very smooth. So it's hard to get your filament to stick to the glass. So we have used the aluminum because it's an excellent conductor of heat to even out the heat in the bed. The glass because it's very, very flat. And the PEI coating on top gives the filament something to actually adhere to as we're printing.
So I was just wondering, you've talked about some of the different pieces. So for this particular printer, did all of these pieces come with it, or did you kind of, make it as a Rector set? And hey, I'm going to get the glass. I'm going to get the other pieces to make this work.
So we'll get into some of the details on that a little bit later. But the answer is no, it didn't come with that. This printer came with the aluminum bed. And it actually came with a plastic flexible sheet that sticks on the top of the bed that's got some surface to it. And it wasn't PEI. We'll talk about PEI in a minute. It was just some kind of plastic.
Yeah.
So I added the glass, and I printed on glass with masking tape and some various things for a while, and then I moved into the PEI. And speaking of PEI, since that's a topic, do you want to talk about that? It's polyethyramide is what PEI is. It's I believe a 3M product.
Yeah, PEI, it's a 3M product. It helps bed adhesion and part removal at the same time. It's for lack of better terms, it's a good insulator between your part sticking permanently and your part being able to be removed. It helps it stick, but when it cools down, it releases the product. Whenever it's heated up, it helps it adhere to it.
And it's essentially, you'll find the glass beds have coating on them nowadays.
Yeah.
The PEI is a coating, and usually the coatings, no matter if it's a PEI or something that's applied to the glass, it's a very micro fine coating that essentially the filament will stick to the coating, and it's if you were to draw the head across the bed, you're looking at basically dots, whereas glass coating, glass coating, glass coating. So that's what helps both the adhesion and the release.
Yeah, I mean the bed type I use, the bed on my printers are a metal with a PEI coating on it. The metal I use is magnetic that I can take off, flex it to release the parts.
Yeah, I don't have a flexible bed on this, and I'll tell you, especially if you print a part that's got a lot of bottom surface area, it is so hard to get it off of there without breaking it. It can be a real challenge.
Yeah, I mean that's but something this size, the glass beds are perfect on because you're never dealing with anything that can be any bigger than 6" by 6". My printer is 15" by 15", and if I fill even half of that bed with something, you need to be able to flex the plate that it's on to get the part off of it, or it's not coming off.
Yeah, it is amazing how they've gone from technology where it's really hard to get your part to stick to technology where it sticks so good it's really hard to get it off.
I just like that image right there. I'm printing those are 2 wire winders that I make that are 8 inches in length, to give you an idea how big that print bed is.
And you're not going to find these flexible magnetic PEI things. That's something that you're not going to find native in these smaller printers. They're going to be in the larger, more expensive printers. So, if this is something you're just learning and growing into and don't expect to do large parts, or you're okay with moving through and moving up, the glass PEI combination works just fine.
Yeah.
But if you're going to do something larger than this, you want to move into something like that.
Definitely, like I said, that's the difference between a $200 entry-level printer and a $2,000 manufacturing printer.
Okay, let's get through some of our preparation stuff, and then we'll take a short break. Let's talk about the things that you want to do to get ready to actually print your first part or print any part.
Or this first thing to do is make sure the bed's level. I mean, that's, as James mentioned earlier, that is key. Now, it's a lot of people confuse it. They get a level out and try and level the bed. That you don't level the bed to the surface. You level the bed to the print nozzle. The bed, you can move each corner independently to raise it, lower it to the nozzle itself.
If we go to Doug's camera for a moment, you can see under here these big wheels on this. Those wheels are attached to a screw, and there's a spring. You can see the spring there. There we go. Here is the wheel, and right above it you can see the spring through the shaft up to the bed. As you turn this wheel one way or other, the 4 corners of the bed can be raised or lowered in very, very fine increments. And so you just go around and around and around until the bed level is...
No, I mean, that's You just move the print nozzle to one corner, move it to the other corners, different places around the bed, and you work your way around. I know when I level my beds, I use 16 different locations on the print bed to get it level. And a lot of people say you can use a piece of paper to judge for the distance between the nozzle and the print bed. I use metal feeler gauges. Paper's too inaccurate.
Paper's a good starting.
Yeah.
You know, paper will get you good enough to get the printer rolling. The feeler gauges are a more accurate and more reliable, repeatable.
Yeah, they were paper, depending on the weight of the paper, the manufacturer of the paper, it can range anywhere from 5/1000ths of an inch to 25/1000ths of an inch.
And one of the problems with paper also is that when you're doing the leveling and you push down, what you do is you adjust the bed until the paper has resistance and pulls out. Well, the problem with doing that is you've now squashed the paper. So if you move to another spot on the paper, it may not be the same thickness. If you use the same spot, it's now thinner than it was.
Cleaning and preparing the surface. Actually, you should do that before leveling it because you're going to be putting pressure on the bed to clean it. So reverse them 2 steps. Clean the bed first before you level. Make sure it's level. Generally speaking, when if you level the bed, you don't have to level it every time, depending on your printer. Some you can go 10, 15 prints without re-leveling. Some every 2 or 3 prints. Cleaning it is simple. Rubbing alcohol or soap and water. Dawn dish soap and water works great. If you need a good deep cleaning, if it's just cleaning dust off, a little bit of rubbing alcohol and a microfiber towel.
I use rubbing alcohol before every print, even if they're back-to-back prints and it was clean. I clean it off because any kind of residual material from the resin can create a non-stick situation for the next print. So I just rub mine down. Even while it's hot, that alcohol disappears quick, but it gets that surface clean. And, I use cotton patches. Do you want to use something that doesn't lay lint or dust down?
Yeah. It's loading and printing FDM filament. I believe it's covered on a future slide, but this type of filament commonly absorbs moisture out of the air. If humidity level in your area is above 20%, you're going to want it in some type of bag to keep it dry. You want your filament to be anywhere from no moisture content. You can get away with up to 15-20% moisture.
Yeah, and that's important. Filament is called hygroscopic. It absorbs water, and ironically, it's the opposite of what one would think. When the filament absorbs water, it becomes brittle. When it's dry, it's pliable.
Yeah, and if there's a lot of moisture, you can print if it has a lot of moisture in it. But you take something that has 50% moisture from humidity and put it through something that's 200 degrees Celsius, it's going to pop and spatter, and you're going to end up with a whole bunch of air pockets in the surface of your 3D print.
And since we're on that, I know we're going to talk about it a little bit later, but I'd like to show what dry and filament. This black filament is currently pretty dry, and you can see it moves, and everything is okay there. We don't have any issues. On the white filament, it snaps. This filament is full of water, and it's not as bad there. It's also not consistent, so you can see how easy it snaps. You should be able to basically bend the filament all the way over on itself. Yes, it'll crease, but it won't break. If it's breaking like that, it's got moisture in it. We'll talk about how to fix that after the break. And with that,
it's just tips for printing. Start small.
Yep.
Print something small, inexpensive, because 9 out of 10 times your first print, you're going to screw it up. It's either not going to stick, going to print wrong, it'll end up doing things that you don't intend it to do.
layers
A lot
don't
of
stick to
basic
each
prints
other.
that you can start with. A lot of people, there's stuff that you can find online. It's called a 3D Benchy, which looks like a little tugboat. Should have brought one. People print them. If you actually, there's a website, 3dbenchy.com, that you can go to. Each little aspect of that print has its angles, diameters, and sizes. People use it to calibrate their 3D printers.
Yeah, and bullet two here is also a really important one. When you first start doing this, well, you know what? It's always really is. This is good advice always. You have to keep an eye on things. I can't tell you how many times I always watch for my base layers until I'm about 10 layers up to make sure I've got good adhesion and everything's working. However, I have been halfway through a print, left, and came back and found this giant ball of filament that's encased my whole print head that's moving around, still squishing out.
So you'll see that on a later slide, but the picture on this slide, that's actually a video too, is my printer. So you can hit play on that, James, and it'll play.
Is this one?
But that's a Wi-Fi camera I have on my printer. That some stuff I print, I've printed stuff that has taken up to 90 hours to print a single piece, single object. So I have a Wi-Fi camera and my printer is connected to a smart plug to where if something starts to go wrong, I can disconnect power from my printer at any time. So if I'm not at home or I'm out somewhere and something starts going bad with it, I can just shut it off instead of wasting time and possibility of a fire hazard.
And a lot of the newer printers have cameras and the ability to do that. If you have these smaller, like more beginner type printers, there is a popular software package out there called Octoprint. I believe that's the name, right?
Yeah, Octoprint.
You add a small, cheap USB camera and a Raspberry Pi, and it'll add that ability for you to add to your printer. Yeah. Okay. Failed print, and then let's do failed print.
Yeah. That should play also.
Here's another video of a failed print. Obviously, these are sped up significantly to show you because, as Jim said,
this is
these
a
prints take
time lapse with a print every 30 seconds, I believe. Well, you can see the parts start to fall off of the print bed and get pushed off to the side, and the printer keeps going. This is one of the times I wasn't home, and about a half hour into it, I logged in and noticed it was starting to screw up. And you can see the spaghetti starting to accumulate.
And when you have these kinds of prints, of course you're wasting filament and time. That's really not the big deal. One of the biggest challenges when you have failed prints is it's usually the disaster that it creates under your hot end.
Yeah.
And then sticks to the nozzle, it sticks to the bottom of the print head, it sticks to everything, and it's very hard to clean up. If you can clean it up. Sometimes I've had to throw nozzles away and start over.
It can become a mess.
All right. I think at this point might be a good opportunity to take our break if the timing seems appropriate to you guys. Okay. We'll continue with filament and move into resin and troubleshooting after we come back. Okay, thanks. Welcome back. Hopefully everybody got a moment to step away, and we'll keep going here with, we were just starting to talk about dry filament, wet filament, and what happens, some of the things that are wrong with that. So let's talk about storing your filament so that it does stay dry. So I will tell you, in the Colorado climate, generally, you don't have too much to worry about. However, I installed a whole house humidifier because of the dryness, and I started having filament problems. So storing in a cool and dry environment is important. Keeping it out of the sun is important. This is how I resolved my storage problems. You can cut to Doug here. I bought these very inexpensive filament storage bags that, and you can see it's vacuum packed, if you will. And if you look on the back, you'll see there's a little silica gel pack back here. I store my filament in there. These bags have a little one-way check valve in the corner, and you simply put this little pump down on there and pump the bag out, and that keeps my filament extremely dry, even in my fairly moist air in the basement, which is a little healthier for our skin. And
Some brands of filament, well, that your filament, and anytime you buy new filament, will come in a vacuum sealed bag.
Yep.
Some of the filament manufacturers have started putting it in reusable suction bags just like that. So if you find one and you like that brand of filament, it might already come in a vacuum bag for you to reuse.
yeah, every filament I've ever bought, it comes in one. I have yet to buy one that's in a reusable one, but
That's fairly new.
these bags and the little kit to do it are really inexpensive, so that's a cheap way of doing it. I know Jim uses the desiccant packs. I meant to, I mentioned the desiccant pack that's inside of there. They're the same little gel packs as you find in every piece of electronic gear that's shipped and everything. That they have the little granules in there with the light. You can eat it once.
Yeah.
You can eat almost anything once. So, but it's not a good idea.
As James mentioned, Colorado with the dry weather, you generally don't have issues unless you have a whole house humidifier. My house, I managed to have it separated enough to where upstairs stays at 35% humidity, where our basement is managed to stay around 20% humidity level in the basement, so I generally don't have an issue with filament getting saturated.
And
Anything below 25%, you're generally safe.
yeah.
Optimal if you can get it below 15, but if it's below 25, I wouldn't be too concerned with it.
I was blowing up too many electronics as walking across the carpet and touching them, so I have a humidifier. So, yeah, there are multiple ways of storing the filament, but this is the simplest way. So, what happens if your filament is already dry and, is wet and cracking? All is not lost. So there are
Multiple ways to dry it. You can put it in a basic tub, get a storage container and fill it full of silicone packets. You can buy the desiccant packets you can get off Amazon. You can get 100 packs for $5 and stick them in a storage container. Put your filament in it for a week or so and it'll dry it out.
And then this, did you talk about the oven?
No,
Yeah.
I haven't talked about the oven yet.
So you can, this is a $20 or $30 appliance. You can buy them in single reel, double reel, big reel. This one's very inexpensive. This is the most common, beginner-sized filament spool. And this is exactly nothing more than a heating element and a fan. And you can put it in here, set the timer and the temperature, and recover if your filament isn't terribly saturated, you can recover.
Usually,
I was able to get almost all of mine back to healthy state.
generally with that type of dryer, you're looking at anywhere from 6 to 10 hours, depending on how saturated it is. But generally, minimum would be 2 to 4 hours.
And honestly, it doesn't hurt to overdo it. These things are low enough temperature that if you put it, I often just set mine for 12 hours and let
Yeah.
it go at a lower temperature, and I've gotten very good results in recovering the
And there's
filaments.
you can even take the filament dryer, if you're always using the same filament for prototyping, you can set the dryer up next to your printer and feed the printer directly out of the filament dryer.
As a matter of fact, this dryer, if we go to Doug's camera, has a
Small hole.
It has a little hole with a little bearing surface on it to do exactly as Jim mentioned. The filament will come right out of there, right out of the dryer into the printer, so that you don't ever have to load it at all. And so that's another option. It's also got a second hole here on this front piece, depending on where your printer feeds. For mine, as a this one would be a better hole to use here because it feeds lower, but you have a couple options in the dryer there.
You can also use your oven at home. I wouldn't use it if you're with ABS filament or ASA, but PLA and PETG filament, turn your oven on the lowest setting, let it preheat at 150, 175 degrees or as low as it'll go. Turn it off after it's preheated up to that temperature. Set your filament on a cookie sheet inside the oven. Let it cool down naturally. Over the 4 to 6 hours it'll take for it to cool down, you'll drop the moisture level in the filament.
Yeah, and the same chemicals that are dangerous to breathe while printing the ABS and other filaments are same ones that can impregnate the oven and cause issues with your food safety. So it's best if you want to dry that filament to use a
dedicated dryer for that. You can also, if I have an old food dehydrator at home, set up your food dehydrator, use to dry your filament. Work just as good.
Okay, so before we get into resin printing, let's talk about some of the details about bed leveling, some of the things available for us there, some of that stuff. On this printer here was originally purchased. It's made by a company called Creality, and this is an Ender 3. It started life as an Ender 3 version 1. It had almost nothing. It was just a very, very basic printer. And the nice thing about many of these printers is the modularity and upgradability of these printers. Over time, I added a touchscreen controller here on the bottom. You can instead of having to deal with the printer through a USB cable all the time, you can operate all of the prepare. I can heat the bed, move the heads around, preheat the PLA, preheat the PETG if it's got settings in it for preheating the element types, cool down. It's also got another thing I added to this printer that it did not originally come with is this little sensor, this little guy right here, which is called a BL Touch. And as you can see, it's got this is actually a micro switch and a solenoid. There's a little pin on the bottom here, and it is currently retracted up there, and you can see that the color is red, or it's actually pink on the screen. But
Pink, purple.
Yeah. What this is currently the solenoid is holding the sensing pin up, but that is a sensor to detect the spots on the bed as it moves around. And let's see if we can do a automatic bed leveling. So the first thing we do is home, it will find the home position. Because these printers are stepper motor driven, it is called an open loop. There is no feedback. All they know is I told the motor to send off so many steps, and I know how far it moves in those steps, but it doesn't actually know what it did. You just saw the solenoid drop the pin in the BL Touch, and it used it as a sensor to see where is the actual bed. That's how it found the Z position or the vertical position. There are micro switches on the X and the Y. If I mentioned earlier that we have wheels on the four corners of this bed to get the bed leveling done. And for years I used it just like that with nothing more than the wheels and a sheet of paper or the feeler gauges to set up the leveling. But it's not perfect. And you can actually get a better print with a bed leveling system like this because we'll run a bed level to show you what it looks like. The machine is going to probe a whole series of points all over the bed and learn how far up or down each one of those points is in relation to the last and all the others. And it builds a 3D map essentially of the level of the bed. So while it's printing, if it knows that this left corner, or one corner of the bed is slightly lower than the other, it will actually, as the print head is printing your part, it will actually step the Z head up or down to try to maintain the exact distance between the print head and the bed. So you can watch, we'll run automatic bed leveling here. And you'll see it's going to drop the pin. First it zeroes everything out. It's going to go find the center of the bed. It turns green. And you can see the LED change, that's a sense. It pulls the pin up so that the pin doesn't get sheared off while it's moving. It drops it off, senses, and now it's going to move. I believe it senses 16 locations on the bed.
Yeah, moving 4 across, yeah, so that'll be 16 locations.
And so it is learning right now what the bed level is in relation to everything. And when it's done here, we'll show you what it learned. Actually, we can do that right now, Doug. If you can zoom in on this screen here, you can see that it's showing the relative positions of each one of the, of each one of the locations. Now you'll see there's green, blue, white, and now kind of orange locations. I mentioned earlier that the bed leveling can only correct up to a certain amount. You'll see up in this corner we have a red number here. The bed is manually the bed is out of level enough that corner is not within the tolerances of what the BL Touch can fix while it's printing.
And you can also use that display to know which corner you should raise or lower for the corner to get it closer to level using the manual adjustments and then rerun the auto level again afterwards.
But now, after you've got your manual adjustment done and then your BL Touch done, it's got this mapping. That is a really good setup for making sure that your first print is actually going to stick to the plate and the layer heights will be appropriate. Mm-hmm. Even if you get the print to stick, your print may or may not be very accurate because if the one side is lower than another, the thickness of that layer will change, the adhesion of that layer will change. There's a lot that changes in there that will affect the quality of your print.
It's like I think looking at that the graph that was on there from each point, if you look at the one corner, if I read it right, it was 0.65 millimeters.
Yep.
Positive, which means that's 0.65 millimeters higher than the center of the bed. The other opposite corner on the back left side was a negative 0.23. So that's low. So if you raise that back corner, the center will act as a pivot point. Raise the back corner to lower the front corner to get it closer to true level without any software mapping on it.
And if you think that's almost a millimeter out across diagonal across the bed, that's a pretty massive amount of change across the bed.
Yeah, right now I know my printer, I'm not sure, I'm not very familiar with this one, I'm somewhat familiar. Mine, while it's printing, I can micro adjust everything from 0.05 millimeters, but it will only allow me to adjust up to 0.5 millimeters total. To where if I notice it seems like it's printing a little bit high off the bed, I can lower the Z-axis slightly up to 0.5 millimeter to bring it closer to where it should be during the printing process.
And I want to take a quick little sidetrack here, because if you're new to 3D printing, a lot of folks go, well, what am I going to 3D print? What are good things to start with on 3D printing? And one of the things you'll see lots of it on this one. One of the things that's a great thing to start with, if you start with a base printer like this that doesn't have a lot of bells and whistles, you print accessories for the printer. So some of the first things I printed on this printer are, for example, this arm up here.
Filament guide.
This is a filament guide. So when the filament is on the roll, and this is where it goes down here into this tube, and you can see the angle into there is not very, very good. So it goes through the filament guide to give it a little bit of an angle so that it reaches into the feeder better. So that's a 3D printed piece. The little tool holder up here in the corner that holds all my Allen wrenches, and it's really a good idea to have a set of good little close-in clippers, the screwdrivers and wrenches and all the things to adjust. If we look down lower on the printer, this particular one here has a cooling fan for the electronics, for the stepper motor drivers here, and it's open on top. So when you have a failed print or something like that, it's real easy for little chunks of filament to fall in the fan and clog the thing up. So I printed a little fan redirector that blows the air out the back. And so there's little pieces all over the printer like that have upgraded the printer using it itself to just generate more parts, more usability of the printer itself. So great place to start learning is print parts that support the printer itself. There's this is the factory filament holder, but it's still a big long loop to get it in here. There are parts on Thingiverse and some of those others you can bring that mount the spool over here so it feeds directly into the feeder. So there's a lot of options there. You want to add anything?
No, that's a big one. Is start. I mentioned earlier and just mentioned again. Start small.
Yeah.
Not only will it help you improve the setup in that, but your first few prints, you're gonna mess something up. It's not gonna come out perfect. So start small. Then you only have to wait an hour to see if you messed it up, or instead of waiting 8 hours to see if you messed up.
And since we've been talking about a few items that are on the back of the printer, you don't access the back of your printer almost ever, but you can see this cable coming in here is the cable that powers the bed heater. This is which is basically just a printed on resistor on the plate below there. It's on the PC board that's sandwiched to the aluminum. You can also see some of the micro switches. Right here is one of the ones for the X-axis homing, and then you can see up here this one has a single axis Z drive, or a single rail Z drive. The stepper motor drives this Acme screw up and down to raise and lower that, and the other side is just passive, captured by bearings. And of course over here we have a switching power supply, which, since we are an amateur radio group, we should talk about not just the power supply, but 3D printers, regardless of the noise from the switching power supply. We have stepper motors here, which operate Often all of this wire, nothing is insulated. It's all just ribbon cable. These things tend to be very RF noisy. So don't start a 16-hour print right before a contest. They're very hard to mitigate the RF noise that comes off of these, and it doesn't seem to matter how quality the printer is.
No.
Anything from the basics to the more expensive ones seem to throw out a lot of noise.
The more expensive ones are a little
Better.
bit quieter, but generally speaking, they're not.
Haven't had any issues into it. I transmit legal limit DXing and stuff, and I've never had it skip a step, fail, anything like that. They seem to be pretty well there. Last thing to note here, almost all, I think all printers have, an interface way. This particular one, you can drive it from the USB cable from a computer, or what I do is once you have your model all sliced up and ready to go, you put it on this is a micro SD card, and then once you insert it in there, the display will show you what's on the card, and it'll actually usually draw a little picture of the model that you can select to print. So that's how you get your data to the printer in order to print it.
Generally speaking, the interface ones where you plug direct in and drive it from your laptop or desktop, if you're in the middle of printing, you can't turn your computer off.
Yeah.
I always recommend put it on an SD card or a USB flash drive and use that in the printer itself. That way it's standalone and you never have to worry about one issue causing another issue.
Yep, I agree. It's a good practice to try to use the SD card slot. Okay, so I think we've went over most of the printer parts and some of the things to watch out for, our setup, a lot of that stuff. Let's move on to some of the examples of what things look like that are printed with different filaments and what some of the challenges and things are. Jim, Jim showed you this one to start with.
Yeah, this one is printed with using PETG filament with a carbon fiber impregnation. It's going to say they're roughly 15% carbon fiber filament, which makes them extremely rigid, extremely strong, and durable. This one's also with the PETG carbon fiber filament. The other stuff, these orange ones are printed with straight PETG filament. I generally use PETG for everything on top of PLA. 9 out of 10 times I'm printing something that's going to be exposed to the elements or chemicals. PETG has a good UV resistance, works good outside. The glass transition temperature that we talked about earlier is fairly high, not as high as ABS, but high enough to where I haven't had any issues inside a vehicle with it, unless you're sitting in the middle of the Arizona desert. I wouldn't be too concerned. If it's going to be that hot, why don't you crack your window a little bit, get some circulation so it only gets to 130 inside your car instead of 180. I have some stuff that's printed with that filament that's been outside at my house, antenna parts, for going on 3 years with 0 issues. So UV resistance is very good. I don't have any, or this is actually printed with PLA. And so you can tell they look similar. The PETG will have a little bit higher gloss until you start getting into the additives into it.
And this one is also, this is a small adapter that holds a power, I'll put it down here, Doug.
Yeah.
It holds a power pull plug in the bottom and a DC coaxial plug. It's a little adapter that is designed to convert Elecraft KX2 and KX3 radios into power pull instead of the DC coaxial. It gives you a little thing there. But if you really zoom in there, you can see the shininess, and you can also see the lines, the layer lines on the piece itself. So it's fairly smooth and strong, but you can definitely see the layers that were generated with that.
Yeah, I mean, just towel line. Some of the stuff like these orange ones that I made, this is to make my own, essentially a homemade arrow antenna for a 2 meter, 70 centimeter Yagi, to where it just clamps around a piece of 1-inch PVC and use aluminum arrow shafts for the elements. That's something I designed and printed myself to make my own with antenna modeling. I have some other stuff that I'm playing with for antenna modeling, which this is for a 2 meter cubical quad, or could use the pieces for any size you wanted. That's printed with PETG, that you just insert the aluminum arrow shafts the length you want and put the wire around the outside edge. That also goes onto a piece of 1-inch PVC for the mast, or the center support, the boom. And that can be made, I can adjust it if I want to use it for 2 meter, 70 centimeter, 6 meter. I don't know if I would use it for anything lower band than 6 meter, because then you're starting to deal with a lot more weight. But I think you get away with doing a 6 meter cubical quad with it without an issue.
And you can see, you know, I think this demonstrates kind of the quality of the printer itself. This is a little paddle, a CW paddle that I bought. N0SA designed and built this. You can. This is printed. We're not 100% sure. We believe it is a carbon fiber based filament, but you basically can't see the lines.
Yeah.
You can't see the layers in this. He printed this on his 3D printer, and you would not know if you saw this in your own hand. You would swear this was cast.
Yeah, it's either carbon fiber, or a good possibility it might be ABS.
Yeah, and it's you know, if you look at that compared to my little El Cheapo printer, where you can see all the layers and lines, they're very different. Not that this is better; they're both equally great parts, but there is a big difference in the printer quality, the printer resolution, and the material used, the filament used to print.
Yeah.
So before we slide into some of the resin printing, do you want to introduce some of the design elements?
Yeah, we can. We'll go over, let me. You go to 2.
Good.
Hey, this is using the Shaper 3D software that I use for designing. This is something I designed to make a 9-to-1 un for a portable antenna that has the outline, or uses a 140 toroid for the 9-to-1, so it's nice and portable, small, and I believe this is the SO239 hole in it. When you get into modeling stuff, I mean, I can go through and adjust this model some if I wanted. This is all done with using an iPad, which makes it nice for modeling stuff. It allows you to zoom in and say if I wanted to switch to a BNC type connector, I can change the size of that center hole simply by taking that and going it in. Measure how big the adapters. I know BNCs are smaller in the SO239, so I could adjust the size of the hole to use a panel mount BNC connector instead of the SO239.
And I think that also, what you just saw with Jim changing the size of that hole, that as you saw that it was changed in 3D.
Yeah.
He didn't just change the 2D surface of that, it changed the entire bore all the way through that 3D part in one swoop.
Yeah, and it changed. Once you have something designed, it's easy to go in and modify it to change the different sizing aspects. If I wanted to go to a type N connector, which is larger than an SO239, I can make the hole bigger. You can move the dimensions of a hole. Say if I needed to, that selected the whole thing, but if I needed to move this, I could go, or move and rotate. Then I can take that and say, oh, I need to move that over 1.5 millimeters to open it up to where I can move each one independently. You can move the holes as a group to move it around the model, which is all fairly easy to do once you learn the basics of modeling. I will close out of this. Let me open up a new area. If you can see, the center axis will give me the view plane, which is your X, Y, and Z axis. If I wanted to sketch something on there, and it allows you to pick which axis you start your sketch on. So if you're starting from the base model, you can jump through and do everything else, a line arc. Let's go in to make something like that. Right now I have it set in inches. You can also adjust everything to, if you're using inches or millimeters, centimeters, inch, foot for measurements. There's that, and then if I take it, and you see how whenever it was flat, it was tanned where it just showed the outline. Whenever I rotated it slightly, it opened it up like that to where now I can raise that up for a standard box. If I didn't want to do a standard box, I want to do an empty box. I can select the outline, and then on the side you will see an offset button to offset the edge. Say I want to didn't select all of them. So let me select all of them, do offset again, and now if I draw over, see how it offset the edge to where now the distance between that inner line and outer line is 10 millimeters. It still didn't select all of them, but we'll just go with that. So now if I do that, say, okay, I want that. That's fine there. Let me draw a straight line to fill these in through there. So where now you can see that now I got two shapes to where I can extrude that center one. I don't want to move or rotate anything. Get out a sketch. The base of it needs to have a 7 millimeter thick wall. I always do that. Do the outside first. That's one of the learning curves that I still forget whenever you're extruding stuff. If it has an interior and exterior, you generally want to do the exterior first and then extrude the interior of it. Why did that hide? Oh, that's why sketches were hid after I did that. If you open up the folder over here, you'll see it says body 1, sketch 1. Sketch is the sketch itself, and the body is the body of the object. Now with doing two separate things here, whenever I extrude this, I say I go up 7 millimeters on that, it'll show two separate bodies to where I can adjust this one independently of the outside one, but if I select both bodies, I can do a union and make them one piece. To where now, if you go to the inside, I can add a fillet, is what they're called, or a radius to the inside curve to soften the edges. Or if I go the other way with it, it'll add a chamfer, which the chamfer is just a standard 45-degree angle across it. You can do the same thing on outside edges, a radius or a chamfer. There's a lot of options now. Just for real quick, if I needed to add something to this backside here to add an SO239 connector, if I select that and then sketch, it'll allow me to draw directly on that. To where now I just added a circle in there, exit sketching, and now if I go through, I can extrude that way, and it'll put a hole there to add an SO239 connector for. an antenna. Or if you go the other way, it'll extrude a tube out the other side. So you can take a flat object to make it three-dimensional. Which you can have a class for days on 3D modeling. Yeah. But that's the basics of it. Think of something two-dimensional and then start off with the two-dimensional object and make it three-dimensional where you want it to go to.
Software's come a long way.
Yeah. So we want to go on to resin printing.
Yeah, so we're not done with filament. We'll come back because there's some common things that we'll address at the end that are common to both kinds of printing. But let's move on a little bit to resin or SLA, which is stereolithography printing. Process that uses photopolymerization, that's an easy word to say, to create highly detailed and precise 3D objects through a resin-based 3D printing that operates by selectively curing liquid photopolymer resin layer by layer. So this is a fairly entry level. It's slightly larger than the smallest entry level printer, but there's some really big differences between this and a 3D print and a FDM or filament printer. You'll notice, oh, there's some resin. There's only one axis on this printer, the Z-axis. There is no X and Y. The way this printer works, this tray here, as you can see, it's see-through. It's got a drum-tight special material on the bottom. This is the resin tank. This is where the resin that you pour the liquid resin into. And down here on this is a very greasy rail. Down here, this is a 4K LCD screen. And it's just a monochrome screen. And beneath it is a very, very high intensity UV light source. And the way this works is the tray goes on here, you fill it with liquid. This build plate slides down to the bottom. It has a micro switch that's been set up so that when it's home or bottom of the Z switch, this plate is basically touching the bottom plate there, the bottom drum-like material. And then the image will slice. Same thing with the slicing. We still slice just like a filament printer, but layer by layer, that the LCD screen will expose or clear out. It'll stay dark for the whole thing and only open up where the layers to be cured are. So the first layer with this plate all the way at the bottom will cure the first layer to this plate. And then this plate will come up, and it doesn't come up one layer, it comes up about 1/4 of an inch to allow the resin to flow back under the plate. Then it pushes down one layer thinner than it was, and it cures that onto the resin above. And it just keeps doing that up, down, up, down, up, down. So your model is being built on this plate upside down, and it comes up out of the resin as it's being built.
One advantage of the resin printing over regular filament printing is the resin printing, you can fill the entire build plate and it'll take just as long as if you have something very small in the center of it.
That's exactly right. So I often, if I'm building like multiple things, that if I want to build 5 of these little adapters that I had, 5 of them take the same time as one, because I can place them all over the build plate and they'll all layer together. So Doug's got into the screen here. If we go to, I'm going to take the build plate off for a moment and show print. And there's one of the models. I I'm going to show you, this is what this is. This is a little box that I did. This is actually, it holds a LiPo battery. It holds Elecraft batteries as just a little protection box. I realized that as I hike around with those in my backpack, an unprotected LiPo in your backpack, if you fell on it, might not be the safest option. So I built a little battery box. But if I'm going to go ahead and select, this is going to print 2 of those at the same time. You can see the model there. And it's got 2 boxes and 2 lids. So I'm going to hit go. And normally, so you're going to find, now if you zoom out a little bit, Doug, I've got the build plate removed. So this plate, as you can see, will screw on here, and it's slowly moving down to the tank. I'm removing this just for the video clarity for a moment. It's going to slide all the way down to it finds the Z home switch, and I have calibrated with the adjustments here. You can see there's screws on the side of the plate to make sure that when you originally level this out, the plate is perfectly flat and in the right distance from the screen. But it's going to come to the bottom. And I'll warn you to just watch your eyes because there is actual UV coming out of this. But you can now see there is the first layer of the 4 boxes being lit up through the screen. And the first layers are fairly, they're fairly long exposures because we really want the material to stick to the build plate. The build plate is an aluminum plate that's got almost like a sandblast type finish on it. There you see it stopped. The thing is coming up just a little bit. And now it's going to go back down because it let the resin flood in. And there's layer 2. And so on and so on and so on until all of the layers are built. I'm going to stop that because... And you'll notice the cover for this that you have on is colored. This keeps UV out from entering there as well as protect your eyes from the UV. You actually won't be able to see UV through the resin. It's more importantly, this cover keeps UV from coming in. Why? Because UV is what cures that resin. And I will tell you, my very first print, I actually was running this device in the basement, and I do have a small basement window. And when I got done printing, I had this beautiful print hanging off of the build plate, and then I started emptying the resin tank to recover my uncured resin, and there was a single 1/4-inch pillar stuck to the bottom that rose all the way out at a 45-degree angle. There was a beam of sun coming in the window and hitting this. And I didn't have the cover on, and it cured the resin all the way through 1 inch thick of resin and made a little model there. But that's really all there is to the printing. The build plate here, as I said, was aluminum. You can see it's a little bit of the marks from releasing the models. The models stick to this incredibly well. And so, for example, that part we just saw was being built like this. And, as this was stuck to the plate, this dips down, cures, comes down, dips down, cures. And when you're all done, you've got all these parts stuck to the plate like this. So you have to use a fairly stout paint scraper type thing to peel them off of the build plate. So I just wanted to start with a basic understanding of how the resin printer works in theory, so that as we get into the pieces of it, you'll understand what we're referring to.
The last time I went to the dentist, I had a little piece of a tooth chipped away, and they put some sort of resin and used what looked like an ultraviolet point source. Is that similar technology to what you're doing here?
It's exactly the same technology. Yep, it's the same. Of course, those are human grade resins and things
Yeah.
like that, but it's exactly the same thing. The resin cures incredibly fast.
Yes. And it's
with-
incredibly strong.
It's very strong. Yeah.
This is similar strengths, so maybe.
Yes, but
Okay.
so resin is changing a lot. Resin used to be incredibly expensive and nowhere near as strong. That's changing a lot.
Okay.
So speaking of that, let's talk about some of the types of resin and some of the properties of the resin that you can buy. Standard resin, is a good balance between the finish, the flexibility, the hardness, and everything else. The world where resin printing really started in becoming affordable for the hobbyist were folks that make tiny little models like Dungeon and Dragon type models, because the detail, this screen at the bottom of this printer is a 4K screen. We just talked about filament that's coming out in 0.4 millimeter.
0.4 millimeter line width and a 0.16 millimeter line height.
So that's technically the smallest resolution, if you will.
Yeah, for a feasible time. You can get down to, I have nozzles that are 0.2 millimeter nozzle width, and I can print down to a 0.04 millimeter layer height. It gets extremely detailed, but a print this size right here that James made with his other printer at looks like maybe a 0.16, maybe even a 0.2 millimeter layer
It
height.
was a big layer height, yeah.
It would take about 14 hours to make this one little part.
Yeah. And this was about 15 minutes.
Yeah.
So, but in here, technically the resolution of the finest layer is 1 pixel
Yeah.
of a 4K screen that's about 7 inches around. So the resolution is significantly better.
Yeah. To where that resolution might take you an hour or two.
Yeah. And, as we talk about the resins, there's standard resin, there's flexible resins, right? So when you're all done, it is a flexible part. Kind of think of kids' toys, like a Happy Meal toy or something, where it's hard plastic, but it is flexible. There, you can buy that. I tend to almost exclusively use tough resins. This particular one I've had really, really good luck with. It's made by a company called eSun, and it's called Hard Tough Resin. This has cured properties equal to or in excess of a lot of filament resins. It's very, very tough when it's cured. And then you've got high temp resins. There's resins for almost everything. They're significantly more expensive than filament, but there's a lot more range of what you can do with them. So this is kind of their. Oh.
Yeah, Doug's asking what's the approximate price class for that printer that you've got there.
And I want to say that this has now been superseded. Everything gets superseded so quickly, but when I bought this printer, it was about $250. So this used to be $1,000 printer. Just not all that many years ago, the prices have really come down. So this is very comparable to a filament printer at this point. The resin, however, I'm not even sure. I haven't bought filament in so long.
Filament you can get some of the cheaper PLA filaments for $15 for a 1 kilogram spool.
And that'll make a lot of parts. Yeah. This will make a lot of parts too. This is I don't know how much is in here. This much. You can make a lot of parts in this too.
Looks like it might be 24 or 28 ounce.
28 ounce, yeah, something like that. But yeah, this is this is more like $40 for a container of resin like that. The neat thing is the slicers, whether it be filament or resin, they'll tell you how many kilograms of, filament or how many ounces of resin or milliliters of resin.
But the backtrack a little bit. They had asked about how much that printer is. The printer is $250 roughly. You can find them $250, $300. Keep in mind that's the printer itself. You also need additional equipment on top of that. So don't walk away thinking I'm only going to spend $250
Yeah.
for a printer. That's not the case. You need additional equipment on top of that, which James will get into. I just wanted to put that in there now.
That's a really good point.
Hey, that might answer my question, because that's what I was wondering. You know, you've got the cover for that, and looks like you've got some other toys that I guess you'll talk about. So that's on top of
Yeah.
the 200, 250 just for the printer.
Yeah, and so we'll get into the print, washing, and hardening. By the technical spec, you don't need anything more than this. You can successfully print, then clean and cure your print manually with alcohol and the sun. But you're not going to have as good a quality and as good luck as if you use the additional pieces. So we'll get into it.
For a beginner, I would recommend all the equipment, and then you could, for bigger part, when you graduate to bigger stuff, then you can get away from some of the equipment. But for quality wise and stuff like that, I would recommend all of the parts.
Yeah, and Elegoo is who makes this printer. You can buy it as a package. You can buy the print, washing, and curing station, and which we'll get to in a minute, and the printer all together, and it's discounted whether you bought them separately. This station is nowhere near as expensive.
Before you're done, there was a question online about cost of resin.
Can you use the microphone?
I'm assuming you'll tie that all in.
Oh, the cost of resin versus cost of filament. Yeah, I think we just we started to address that. 1 kilogram spool of resin is your most common size. 1 kilogram spool of filament is your most common size. And as Jim mentioned, you can get this as cheap as $15. Some of the more expensive ones are...
Like the ones I use, the PETG with carbon fiber embedded in it, run about $35 to $50 for a 1 kilogram spool, depending on the color. Color changes pricing also. Yes.
Yeah. And just for an example, like this is a part that Jim printed with the carbon fiber that's an adapter for his shop vac.
Adapter for my shop vac to connect to my miter saw.
And what was the estimate of amount of filament used for
Amount of filament on that was roughly, was it 70 grams?
So that 70 grams out of a kilogram spool gives you a scale of how many of those you can make from one spool of.
I think I calculated I can print 8.5 of them with 1 spool of filament.
Yeah, and the same. Honestly, the resin bottle, whatever size this is, they're all about the same size bottle. Mm-hmm. The yield from it's about the same.
Yeah.
The reason is if you look at it, you're making the same part. Doesn't matter if it's made out of that. So, these are about equivalent. And as I mentioned, a bottle of this used to be cheap. Everything used to be cheaper anymore, but a bottle of resin like this is $30 to $45 right now. This is the hard tough resin. The just standard kind of general resins are $10 cheaper than that. So that's kind of the price.
The hard tough is the PETG equivalent to.
So how long have you been in? I mean, you started out with the the original printer. So is it you fairly new to the resin printing, or is
I've been doing the resin printing about 4 or 5 years, and I bought a smaller printer, the same brand, but a smaller physical, had the same resolution, but it was just a smaller build area, and I moved up into this. The only difference in this printer is the build area. Yeah. So, and I've not needed anything more. 4K is there just isn't. You just don't need more resolution than that for anything, and it works just just great. I haven't needed to do any upgrades or changes.
So yeah, I guess you mentioned making models and some things. So I assume now with your skills, you'll be able to repair He-Man for field day.
Yes.
Okay.
We can print a new He-Man for field day. All right, so kind of getting back to the differences between resin and filament. The big one is the resolution. By far, you are just. It doesn't matter how good of a printer you can get really fine resolution with filament printers, but the resin printer is going to be more. It's still going to be more finer resolution.
Yeah, that's
Strength is about, some of the basic resins are not going to be as strong as the weakest filament, which is PLA. But as I said, as you get into some of the tough resins, you're well into the middle range of some of the filaments. And part flexibility. These, if you look at, for example, and here's a good example, Doug, if you can zoom in on these parts here, and if we could cut to Doug's camera, this is the exact same part printed with, in this hand is a PLA, and in this hand is a hard tough resin. And you can see, now this is not a great example of a 3D printed part because I was learning fairly early with this. But if you look up into here, you can see I had a hard time getting a nice, clean, short disc there. And essentially it's because it's hanging in midair. Whereas the resin print, it's flawless. This little area is absolutely flawless. You really can't see the layers in this because they're so fine compared to, you can see on the back of this part, you can see all the lines and the layers, whereas here you really can't. I mean, you can see the layers, but they are incredibly fine. The other part is, if you look at the PLA, you can see how flexible it is, and the resin printed part doesn't move. It's much harder.
We have a question online, James, from Ben Rodman. So on the whole, resin is about how much more costly for comparable render. Can you discuss pros and cons and why you would choose one over the other?
I mean, that depends. So that's a tricky question a bit. If you're talking about equipment and everything else all together, your one-time buy and then your resins and everything else, it's probably double. It probably costs you twice as much to get started and to buy everything to get going with the resin printers as it does with a basic filament printer. What are the pros and the cons? I mean, the pro is the resolution. The pro is really the fine detail that you can create easier.
The pro resin printing. Another pro is if you have a large quantity of small parts.
Yes.
We'll use James's as example again. If you were to print this with a resin printer on this build plate, he could essentially print 20 of them in the same amount of time you can print one with a filament printer. And because it prints them all simultaneously, to where with the filament printer, it would have to print the first layer for this one, then the first layer for the next one, the first layer for the next one individually. To where the resin printer will print all of them simultaneously.
Exposes each layer all together.
And then for the design, since you did one on each printer, I assume that the original CAD drawing was the same. Did you have to change something for slicing to go from one type of printer to the resin printer?
I took the original STL file, which was the same, and this I did not draw, by the way. This I downloaded off of Thingiverse. Another hand gets all the credit for that. I took the original STL. I used Cura and sliced it for my filament printer, and For this particular part, I used the Chitu box slicer that actually came with this one. I have since moved into the lychee slicer, but that's only difference. I just told it, I told one slicer I have this filament printer and this filament, and I told the other one I have this resin printer and this resin, and said go slice, and I put the two files, and that was the only difference.
In general, the STL file will work for both resin and
Yes.
filament printing. With resin printing, if you start designing your own, you can do things slightly different if you know it's going to be resin printed that aren't capable with a filament printer. You can do steeper overhangs, you can put pieces closer together for it to have closer tolerances. Just little things that 99% of the time you don't need to worry about.
The other thing to remember is, so Jim made a really good point. If you have a part that, so because the build process is inverted with a resin printer, so if you're building something up on a filament printer and the model is connected all the way around, and then all of a sudden there's an arm that needs to come across and connect to the part mid-height, you can't do that in a filament printer without what's called support, because you'd be printing in midair. The build plate is now, an inch away, and you need to print something way over here that's not yet connected to the model. You would have to build support. So it builds a little structure on the filament printer to support that thing until the connection happens. Then you cut that away. On the resin printer, you don't have to have structure because it's building the opposite direction, and it'll stick to the area.
Okay, we have another question online, again from Ben Rodman. Is resin printing less vulnerable to the risk you discussed for filament, like adhering to the plate, bird nests, etc.?
Yes, so I will get to that at the end as we get into troubleshooting, but the answer is yes. In a nutshell, making sure your plate is absolutely flat and adjusted at the right height on layer 1 is about the only adhesion issue you're going to have. So yes. So steps to resin print. We went through all the steps in filament printing. On resin, choosing your resin is number one. What is the ultimate use of the part? So choosing the resin is really step one. Printer calibration. And printer calibration on this printer, for example, and most resin printers, it really is about setting that Z height properly and making sure that the plate is absolutely parallel to the bottom. They've made it really, really simple nowadays to do that. Typically, you just loosen all of your screws and everything, run it down until it hits the Z switch, and then tighten it up while it's sitting flat on the plate. And that's all there is to it. And I guess that covers the build platform leveling as well. That's really, because you only have one axis to deal with in resin, things are a lot simpler. You don't have three axes to deal with like you do there. So then after the machine's all set up and ready to go, you pour resin down into your resin tank down there. Select, stick your, this one I use it has the same thing. There's a USB, this one actually has Ethernet on the back too, but I still end up using, instead of a micro SD, I just use a USB thumb drive. And I plug it in there with the models. And as you saw on the screen when we did it, the models were choosable as to which one I wanted to print. You click it and hit go. And just like filament printing, monitoring it, just simply so you don't waste resin. There's really less of a mess to clean up if you have a failed print on a resin print, but resin's expensive, more expensive, so you just monitor it to watch it. Resin printing on a part-for-part comparison basis is not really any faster. It can be. Some resins can cure quicker, but it's not significantly faster. Now, Multi-part, of
Yeah.
course, is way faster, right? But if you're just printing one part, resin and printing, filament printing are about the same speed to print the part.
So in that printer that you've got there, it's kind of looking at the size of the plate. So is that kind of the limits on the size of that? And then how high can you go? I mean, from looking at that, what are the part dimensions if you did a one-piece box that you could do?
So you can build, the screen is actually bigger, slightly bigger than this plate. So you can use this full build plate area, which I think this one is maybe 7 by 4,
Yeah,
7
4
by
4 by 7.
4 by 7 inch, and height wise, all the way to the top. So you can
6, 7 inches high.
yeah, at least that. So that's, the tower is the only limitation on the height. But the full build plate area is available. Okay, so you have level done it. It's printed. It goes, up and down, up and down, up and down, layer by layer. And now when you're all done, this thing will retract all the way to the top. And you will have this drippy, gooey plate with your parts hanging off the bottom of it. And resin is not a pleasant medium to play with. It is super slimy. It does have a smell. This is something you should use in a well ventilated area, and I always wear gloves when I'm working with the resin because it is both a lung and skin irritant.
Yeah.
It's not super dangerous, but it's irritating enough that you want to protect yourself properly. If you get a little on you, your hands aren't gonna to fall over.
You're not going to need to go to the hospital.
Yeah.
Here's one comment online from Chris Keller. Which design programs or apps can you recommend? I know we've talked a little about some of this earlier. Chris says, I've used Onshore on the web, but I'm intrigued by Jim's iPad app.
The iPad app is Shaper 3D. The original intention of it was optimized for use on the iOS system with the iPad Pros. They do have online or desktop versions that you can use a Mac or Windows. You can also use it on a Windows formatted tablet, but it is optimized for use on iMac and iOS systems.
So run this thing back up home. There we go. So getting back to where are we at with the print? You've printed and the thing is hanging off of there. The plate and everything is dripping with resin. One of the first parts that I printed with the resin printer is this crazy looking. You can cut to Doug's camera for just a moment here. Is this crazy looking this part right here? And what this is unfortunately the printer is on the wrong. What this does though is this allows me to take the build plate off with the parts, and I stick this on and put the build plate on this part here, and it holds the entire build plate at a multi 45-degree angle, so one corner is centered, and it allows all that extra resin to drip off back into the resin tray. It is coming back up, but it's very slow. Assuming there's no ultraviolet light. I print most of mine in the basement. I still put the red cover back over it when it's draining, and that's really a safe way of doing that. As I mentioned, the parts will really stick to the bottom of this plate, so I use my scraper to peel them off. And when the parts come off of the plate, they have the consistency of a squid. They are finished, and they are hard enough that you're not going to just deform them and stuff, or leave, glove prints. I won't say fingerprints because you're wearing gloves. Glove prints in there. But they are slimy. They have excess resin all over them. And they are soft. You can put, nicks in the part with your fingernail or whatever. So the next step in the resin, so that at that point you'd be done with a filament printer. But you are not done. So the next step with a filament printer is to wash the parts. And I cannot get that to go in. Okay, there we go. This is made by the same company, Elegoo, as the printer is made, and this is a combination print washer and curing station. So the first thing we have to do is get all of that excess resin off of the part. So we use this. This has a parts basket similar to you would find in any kind of a parts washer. And although this needs to be changed, the washing medium is alcohol, just isopropyl alcohol. In this case, it's 99% isopropyl alcohol. The liquid resin is dissolvable in that. Should be clear. I've washed a ton of parts and it's time to do that, but this basin has a magnetically coupled, you can kind of see through the side here, Doug, it's got a magnetically coupled stirring plate in the bottom. And it's just like a scientific, you can see all the excess resin that's washed off and settled out of here. So when you start this, and you put it in, there we go. It creates a pretty turbulent wash cycle to wash the parts off. And this one will, if you do it for more than a minute, about every 30 seconds, it spins down and goes up the other direction. So it changes from counterclockwise to clockwise to make sure a very thorough wash of the part is. How long you have to wash depends on the part size. A small part like this part I wash for about 2 minutes. When I was building four of these at the same time, I washed them for about 10 minutes to make sure that all of the resin was washed off. And as they come out of here, now most of that slimy resin has been removed, but they're still soft. So I let them dry. 100% isopropyl alcohol has a really high VOC rate, so it dries very, very quickly. I usually only give it a couple of minutes. And then I put the wash tank away, and now you've got this magnetically coupled plate that lines up there. You change the mode to curing, set some time.
Watch your eyes.
It will not run. This one has a safety that will not let the UV light come out. And when you hit go, you can now see the lights. And you can see the plate is, it's got a microwave style plate where it rotates the part around in front of the UV lights. The base is acrylic, so it tends to pull the light in and let the UV light come up to the bottom of the part, so it cures fairly equally. I do switch mine around so that all parts get a... That curing time also depends on the resin. So the question was, do I have to rotate the part? This acrylic plate does a pretty decent job of getting the UV up to there. I'm sorry?
Do you have to move it up?
You don't have to.
Get it on the inside.
So the answer is no, you don't have to. Usually enough gets around there. I do, because you get a better cure. I'll run it like that, and you'll get a better cure of all the surfaces equally if you make sure that all of the faces hit the thing. To be honest with you, I will cure in this curing station usually just long enough to get the part to be not sticky anymore, or not, it may still have a tiny bit of tack. And then as long as it's sunny outside, I take them and I set them on the front porch for about 5 minutes, and that cures them instant. I mean, they are done. That is a lot of UV compared to what comes out, and the parts get dry and hard really fast. But you don't have to. This will cure them long enough. I had 4 of these running all at the same time on this little plate, so the light didn't hit all of the parts, and it took about 20 minutes in the curing station to get them to where they were hard and safe to take out. Then, at that point, you are done. You have an equivalent part that came out just as if you had taken it off the build plate of a filament printer. So, curing is the last step. The resin, it is ultraviolet, so again, like you can see, this curing station has, as I mentioned, this one allowed us to let the UV through, because normally you don't have that safety issue because the resin's in the tank blocking it. This one, of course, the UV is not. So if I hit start, it does not work until I put the lid back on, and then it will, the LEDs, and it has a safety feature. As a matter of fact, you can see at the bottom here, you can see the color, the purple that comes out of there just a little bit as I do that. So, but that's, I don't remember how much this station cost independently. It seems like it was under $100.
I think they're
Probably over that now.
I think it's 129 or 149 for the wash cure station.
Okay.
The excess shows $200 on the LED site.
200? Okay.
Okay.
And I don't
went
know
up
what they
again.
are as a kit. They do sell them as a kit together, but it looks like this, just like everything else, the price has gone up a lot. You know, that's unfortunately the world we live in today, but. All right, so that's kind of the curing. You know, final inspection is, of course, taking the parts out of there, inspecting, making sure everything looks right. There are still parts that you need to build support with. So if you built that little bridge up that's holding the part midair, you just chop that off and sand it off. Depending on the desired finish, you may sand, polish, etc. The resin does take to sanding and polishing much better than filament printing does. Mostly, and I'll let Jim chime in here, but if you want a shinier surface on filament printed parts, you typically just do a light brushing of acetone to partially surface melt. These you can finish more like if it was a metal part.
So that's PLA filament. Doesn't do good with surface sanding to get it for a finish. You can surface sand and then use body filler or Bondo to finish the surface. PETG, don't even try and sand. Paint won't stick to it, nothing will stick to it. If it's a part that's being painted, use PLA.
Yeah.
Hey, James?
Yeah.
We have another question from Chris Keller. Do resins come in different finish colors, or is all of that after or post-print?
100%. You can buy resins in every color just like you can filament. Yeah, they come in every color imaginable. And I know it's ironically the only, I guess Jim's got some blue and orange, all the other stuff's black. Nothing you see on the table that you've seen in the demonstration today has had any kind of finishing done to it. This is just how it came out of the, that's the finish level that things come out of. That camera hung up again. Okay, so as we start to finish up with resin, cleanup. Cleanup is where the big change happens in between resin and filament printing. Cleaning up from a resin is a little bit time consuming and messy. So the first thing you're going to do is drain your resin tank back into your bottle in a hopefully a subdued light area. like I said, I do most of mine printing in the basement or sometimes here in the shop. So I just make sure I'm not in sunbeams that are coming through. I do, although I don't think it's probably necessary, I usually do drain my tank back through a filtered screen, much like a car paint type funnel. It's a paper funnel with a nylon screen at the bottom. If there is any little cured chunk that would accidentally happened in there, that screen will keep it from getting back in my storage bottle. These storage bottle you can see is aluminum, and then on top of that, it's got a plug in the top that keeps it, super fresh and all that. So once you've drained the resin tank into here, as I said, this resin is really, it's got an amazing surface tension to it. So what I will do is I will take my scraper, and when I'm holding my tank, I will scrape all the excess resin to one corner and finish draining it, because an amazing amount will stick to all the surfaces. Once you have all that done, the cleanup is alcohol. 99% is pretty expensive, although it's the only thing I use for part washing. I just use the regular old everyday brand of 91% for all the cleanup of all the parts. Don't use whiskey. You drink whiskey after you're done with all that. So just straight alcohol it cleans the resin up, no problem. But it's a chore, it's a chore to clean up all. You have to clean up the scrapers and any tools you use. You have to clean the inside and outside of the resin bins. You clean the build plates off. So, it's more efficient if you have to print a whole bunch of things at once than do one cleanup than it is to print one thing, clean up, print one thing, clean up. There's no trick to it other than that. Just lots of alcohol and
A year ago, I started getting into resin printing, where with the filament printing I started 10, 11, 12 years ago. I got into resin printing mainly for printing batches of small items. If I need to print something quick and don't want to deal with the cleanup and everything else, I'll use the filament printer. Use resin printing if I have a whole bunch of small items I want to print.
Absolutely. And so, troubleshooting, as we move into troubleshooting, this is where we'll talk about troubleshooting with each type. But with resin printing, there's very few things you need to worry about. You're going to have probably more success right out of the gates with resin printing than you will with filament printing. Bed adhesion, absolutely. Making sure the bed is level and the Z is set right. You get that right, and that make sure your bed is clean. I do the same thing here. I wipe the bottom of the plate with an alcohol and a non-lint cotton pad or something, and your bed's it's going to adhere. Also, making sure that the exposure time on your base layers is set right. They are exposed longer than all the other layers. So make sure those two things, make sure your plate is set right, make sure your exposure is proper, and you will not have adhesion problems on the plate. If you have parts disconnecting, making sure you've got supports where you need them. And remember that the process is opposite of filament. You're printing upside down from this one. So even though you're building bottom up of the part itself, on a filament printer, you're building bottom up. In a resin printer, you're building bottom up down. If that makes sense, because it comes out of there.
So when you're doing kind of the slicing, can you see some of that, oh, hey, this is going to need a support, or to some of the programs when you build this, some indication that you need to put a support or do something in?
Slicing software will show you all of that. So the Cura Ultimaker slicer that we use, whenever you put the object into the slicer and slice the object, it'll show different colors for different layers. If the color it's showing is red, you need a support there. Good possibility you'll need a support.
Yep.
So
the good news is you can simply say add support and it figures out where to put them and it calculates it. So you don't have to, create some new 3D stuff. It'll do it. But yeah, it's really obvious when you look at it in the slicer software and spin it around, you look for red surfaces.
Yeah.
for Cura, for example.
Which all the slicers that I've used are generally the same. It'll show red surface if it needs the support.
Good for next year. I'm going to volunteer you for Willem for slicer and, a little more on how to make some of these neat things.
More detailed on design and slicing.
4 hours.
You've been voluntold.
Thank you, Willem.
And the biggest tip that I can give for resin starting out, I have yet to find a resin manufacturer or a printer manufacturer that does not have a very comprehensive basic settings chart for the combinations. I can go to eSun and say, I want hard tough resin with an Elegoo Saturn, and they give me a line that shows bottom exposure, exposure time, layer thick, all of that stuff. Put that into your slicer software and you will have success on the first try. You will find that there's probably tweaks that you can make to make it a little faster and things like that. Personally, I find that they overexpose a little bit.
Yeah.
And you can shorten those times, but if you put those times in, you're going to have success on your first print. Which is awesome because you got your new toy and something useful comes out of it is a lot nicer than when you get a big ball of twine or a drippy mess coming out of it.
Yeah, there's nothing worse than your first 10 prints having one fail, and you're new to printing. It is the biggest turn away for so many people.
Mm-hmm. Absolutely. So even though there's more mess and more cleanup and things like that with resin, it's easier to be successful on your first try. Jim's got a great closing slide here. I think before we wrap up, we still want to talk about some filament printing troubleshooting.
Yeah, I mean, it's pretty much the same. Troubleshooting for filament printing, 9 out of 10 times it comes down to bed adhesion.
Yeah.
The slightest deformity in bed adhesion will cause issues. This one I had to force to fail, but this is what is called layer shifting. Layer shifting, if your item isn't perfectly adhered to the bottom or the surface, it starts to print and then will gradually move across the surface. This one I had to physically move the bed while it was printing to get it to fail, just for an example. But you can see it started printing there and then the bed shifted over and it kept printing the whole thing, but it's unusable because it shifted over. On the other part that I showed, it was just this small corner of the print didn't adhere to the bed surface and moved off to the side, but it finished printing everything else without issue.
And honestly, we could probably take you through 100 different scenarios about print failure, but filament printing's been around long enough, and there's so many people that are so good at it. If you search, for example, do a Google image search or your favorite tool image search about failed 3D print and resolutions, there are so many really good charts out there that have a tile of pictures of the example, and they tell you exactly what's wrong and how to fix it.
Yeah.
That is a better source than going through all 200 possibles.
Actually, looking at this, we can go back to Doug's camera. If you look at the bottom of this really close, you can see the bottom layer. I'm waiting for Doug to zoom in here. You can see where all the lines are pretty much squished together there. If you get over to the part that failed, you can see the lines look like they're separated and not squishing together. That tells me that my bed's not level, because one area of the print is printing the way it should, to where when it got over to the base first layer over here, the print head was further away from the thing. So I had to go through and re-level the bed. After I did that, it worked good.
And as far as filament printing goes, there are, even though there's so many options about what could be wrong, bed level is probably the number one thing that can go wrong. Making sure your bed is perfectly level is the number one key. The second thing is making sure that your nozzle distance to the bed is right. As we mentioned, when a layer goes down, each layer does not just lay on top of the next one. The nozzle actually kind of pushes it and squishes it into the last layer. So the level and the distance has to be just right, making sure your nozzle is clean and you don't have fragments of filament on the bottom of your hot end, because they will grab the filament that's wet and drag it and ruin your print. So cleanliness, level, and distances are all really critical starting points. Mark?
So on the nozzles, I know like if you use a pressure washer or whatever for a while, it kind of makes the hole and things a little bigger. So I assume these nozzles wear out after a certain time of printing, or?
Yes. The most common nozzle is a brass nozzle for filament printing that don't print anything other than standard PLA or PETG filament with 0 additives. You can use the standard brass nozzle. Once you start getting into the filaments with additives like the carbon fiber, ABS, rock filament, stuff like that, you want to get a hardened steel nozzle. The downside to hardened steel, it doesn't transfer the heat as good, which is why they don't recommend it on some of the cheaper printers, because the hot ends aren't as good and can't maintain the heat in the nozzle. I generally for my printers, I'll replace the nozzle about every 50 to 70 prints, depending on what material I'm using. And I use nothing but, it's a diamond nozzle. It's a hardened steel with a diamond insert that the filament goes through, which lasts a lot longer. But if you're printing carbon fiber, stuff like that, it still wears out even the diamond nozzles.
And I replace mine every time I gouge the bed and get filament wrapped around it from a failed print.
But
I'll tell you, trying to clean up after a failed print is almost a lost cause. It's better to just let everything cool, peel off the filament that's stuck to the hot end, and replace your nozzle. Just do those steps, and it's almost impossible to clean up a nozzle after a failed print.
yeah, I mean, part where I guess count isn't really a good thing to go off of for when you need to replace your nozzle. If you're printing stuff this size, you could print thousands of them without needing to replace the nozzle. You get into stuff this size with the carbon fiber filament, you might get away with doing 300, 350 of them before you need to replace the nozzle. So it's all on material, has a lot to do with it. But all material does wear out the nozzles eventually.
And we should talk about, the hot end is something we didn't give as much attention to. Jim did address it. The hot end is actually heated by typically resistors. There's usually some high wattage resistors that are clamped into like an aluminum head. There's some insulation around there, and they just pass current through the resistors and get them hot. There's also a temperature sensor sandwiched in that same thing, and a PID controller keeps that thing exactly where it's supposed to be. You'll know, I did mention on my printer, there's a couple of fans. One that cools that's. You definitely want, as the filaments laid down, you need it to cool at the right rate. So one of the slicer settings will be your fan speed to cool for adhesion there. Jim captured, I think that on this closing slide we have here, Jim captured 3D printing so good here. It's often a matter of trial and error. I'm going to say it's more than often. It's always a matter of trial and error. And especially when you're changing config or materials, it's best to practice with the manufacturer's recommended settings and then adjust based on your needs. You will find, especially with filament printing, you are going to have failures. I have several glass beds downstairs that have gouges in them because I screwed up and let the nozzle dig through the bed, and so that they're not good anymore in that area, and so even though it's not really, the good part is most of the things that you mess up when you're learning are not expensive to replace, but there is a learning curve, and it's really easy to get frustrated. So try to use the manufacturer's recommended settings to start with. And then the other thing that was really helpful for me was to find someone that's good at doing this already. Just like our ham radio Elmer, right? Find yourself an Elmer. If you have trouble and bounce the ideas off, they can often tell you, oh, you're doing this wrong. You don't need to invest massive amounts to get started with this. Of course, the more you invest, the more likely the machine's going to produce something on the first try. But if you're really into the experimentation and stuff, you can buy a pure glass bed, put masking tape down, spray it with Aquanet hair spray as an adhesive, and you can actually print successfully with that.
Another good adhesive, if you need it, is the purple glue stick from Elmer's Glue.
Yeah. Yeah. So, but a PEI bed, which will probably cost you, on the small machine like I have, I think that was a $25 adhesive.
My big printer, the 15-inch by 15-inch, was $47.
The PEI is the way to go. Yeah. So, that's kind of our wrap up on getting started with 3D printing. I think, unless Jim, you've got something to add, we can go to any questions.
No, I don't. Like I said, we're voluntold doing slicing and 3D modeling more in depth for next year, so we'll call that a 3D printing 201.
So we'll go to questions if there are any.
Do you have any questions?
We've either done such a good job that there
Or
are
everyone's
none,
asleep
or
at
everyone's
home.
gone.
Yeah, if anybody's got any questions, feel free to come off of mute and you can go ahead and ask them before we let Willem wrap it up for this academic year. We did get a comment. Ben Rodman said, super helpful presentation. Don Colburn, well done, gentlemen. And Chris Keller is much appreciated.
So the presentation will be available online, so
It's a lot of
you can always
good
use it for
stuff.
reference.
Yeah, and the details there.
Thank you,
We'll
gentlemen.
include Doug's
Appreciate
phone
it.
number for questions afterwards.
You don't want them answered correctly.
Okay, Willem, it sounds like I don't see anything else in the print and haven't heard anybody else come on. You want to do a wrap or say something and we'll clean up.
Well, with that, we thank you both for a most excellent presentation. It was extremely informative, so very much appreciated. Jim, thank you for volunteering for the next RMHAM University session or series of classes next year. Again, a reminder, if there's anything else that you are very much interested in hearing about, please shoot me an email or contact us through the RMM website, and we will see if we can twist some arms to put that on for you. So thank you very much again for attending, and again, a very big thank you for our AV team for traveling up to Fort Collins this morning to give us this remote session. So I think I heard Dave Maserowski, Mark Skelton, and Doug Sharp as the AV team, and of course John Maxwell remotely for putting this on. So thank you, and we hope to see you all next October for another series of RMM Universities. Thanks you all, and we'll see you soon.